Okay, inverse trigonometric identity. Okay, first thing I'm going to tell you is I don't need to have the numbers of all your substitutions and everything on these. I just want to see that you can go through the process of how to do this. Focus more on going from step to step legally. Don't break any rules. Don't just, well, I need an X here, so let's just throw an X in there because I feel like it. Make sure there's a reason why you're doing it. Just don't feel that you're obligated to write, you know, number 32 or number 25, whatever thing you substituted in there. Also, keep in mind that these things are angles. Sine inverse x is an angle, cosine inverse x is an angle, and I expect to see those triangles on your paper. So they're part of the identity, is the angles that those things create if we're going to use that side, which I recommend using the side with the inverse trig functions. That's the one to use. All right, now, keep in mind that sine lives in which two quadrants? Inverse sine? 1 or 4. And cosine lives in?
2 or
1 or 2, right? 2 or 1, 1 or 2, whatever. All right. Think of x as being just a regular number. So if it's x, it's a positive. It's negative x, it's negative. It's going to act like a positive or negative number. Okay. So when I see inverse sine of x, that's positive. I'm going to take the positive one, which is the first quadrant. This is inverse cosine of x. I'm also going to take the positive one, which is the first quadrant. They're all positive in the first quadrant. Okay. So what I want to do is I want to invent those two angles there to call them something. And again, you can call them whatever you want. I'm going to call them alpha and beta because I like alpha and beta. But you can call them what you want to call them. Okay, if I draw the sine one first. You know, I just thought of something. Do a little color coding here. We'll do the sine in blue and the cosine in green. Alright, so sine lives in the first quadrant. Alpha, I should say. And, oops, let me get it back over here. And there we go. So there's angle alpha that represents inverse sine of x. If it's inverse sine of x, x is x over 1, the opposite side is x, adjacent, or hypotenuse is 1. That's what sine is, opposite over hypotenuse. Again, x in fraction form is x on top over 1. So hypotenuse 1, opposite side x. If I'm looking at the adjacent side here, I know that 1 squared equals x squared plus adjacent side squared. So 1 minus x squared is equal to the adjacent side squared. So plus or minus the square root of 1 minus x squared is the adjacent side, right? Officially, by the rules of mathematics, you got the plus or minus going on there. Okay, which one should I take, the positive or the negative?
Positive.
Because?
You're not going right.
It's going to the right. So it's going to the right. So officially the square root of this is plus or minus, but since we're going to the right, we'll take the positive square root. So the square root of 1 minus x squared is what this side is. All right? Now, if we take a look at inverse cosine, I'll do this one in green. We're supposed to be in the first quadrant again. So first quadrant drawn. I'm going to draw my vector off into the first quadrant somewhere like so. And I put my right angle here, call this angle beta, which is what I'm going to call that. Cosine's adjacent over hypotenuse, that's x over 1, right? So adjacent x, hypotenuse 1. It's the same two sides as these are, right? Mm-hmm. So it's the same Pythagorean thing. This should say opposite instead of adjacent, but you get the same result. And notice it's going up, so it's positive, so this is also square root of 1 minus x squared. All right. And again, I just drew those just based on the inverse trig function that it's dealing with. The trigonometric ratio for sine and cosine based on SOHCAHTOA that we learned a long time ago and we've used again here recently. And just like that, I can create both of these inverse trig functions. I can create pictures to represent them. All right? The whole Pythagorean theorem, do that scratch your paper. I don't need to see that. But I want to see these triangles on your paper when you're doing an inverse trigonometric identity. I want to see what they look like in picture form. To actually carry out the identity, it looks like this. I'm going to start with the side with the trig identity. So I'm going to write down inverse sine of x plus inverse cosine of x. And that's the left-hand side. You do have to write that down. Don't just like if on the test, a couple you just started under it and you started writing down beneath it. But you actually have to write down the side you're going to work with. So write down what you're going to work with. The very next step, we've already gone to the trouble of doing this, so I want you to rename these two things what angle you call them. So inverse sine is alpha, inverse cosine is beta. alpha minus beta if it was minus, or whatever. You'll get whatever signs here. These will be whatever they are. Maybe it says 2 times sine inverse equals, and then you can do something with it. Whatever, all right? But it's going to have some kind of relationship there. You figure that out. So these, just rename them what they are. And here is the trick to the problem. What do we like better, sine or cosine? Doesn't matter. Sine or cosine, we got to like one better. Sine, okay. Sine. So here's how it looks. I'm going to do sine of alpha plus beta. But I'm also going to do the inverse sine of that. I can take sine of anything, right? Now if I'm doing the inverse sine of anything, the answer is the anything, right? So if I have anything here, if I have 7, inverse sine of 7. If I had dog, inverse sine of dog. It doesn't matter what this is. Inverse sine of that thing's the same thing. Inverse cosine of that thing's the same thing. It doesn't matter which one it is. Take your pick. By doing sine, we're going to use the sine relationship. If we did cosine, we use the cosine relationship. Use whichever one you picked. But again, once you get to the angles, right here, inverse trig function of the same trig function of that angle, stick with sine or cosine though, because they're never undefined. Tangent, cotangent, secant, cosecant are much more hard to get along with, so don't pick those. Sine or cosine. And the sine rule, as we just used in the last problem, is, or actually 2 problems ago, wasn't it? Is sine of the first, cosine of the second, plus cosine of the first, sine of the second. And it just so happens that sine of alpha and cosine of beta and cosine of alpha and sine of beta are present in these 2 triangles here, right? So we have the ability to get expressions representing those things. So we substitute those things in. I get inverse sine. Sine of alpha, opposite over hypotenuse, is x. Cosine of beta, adjacent over hypotenuse, is x. Cosine of alpha is adjacent over hypotenuse, the square root of 1 minus x squared. And the sine of beta is an opposite over hypotenuse. This one is going to be the square root of 1 minus x squared. So sine of alpha, cosine beta, cosine of alpha, sine of beta is all 4 of these things. And again, I got all 4 of those pieces of information from the triangles I drew over here. If I work it out, if I simplify it as much as I possibly can, I'm going to get x squared plus 1 minus x squared, right? What's x squared plus 1 minus x squared equal? Equals 1, right? So we get inverse sine of 1. Where does sine equal 1?
Pi over 2.
Pi over 2. Oh, I shouldn't circle that, I suppose. Pi over 2. There's my answer. That answer is only valid if those triangles over there so I can look at them. If I can't see those triangles, this isn't valid. Because again, I invented these 2. I had to draw a picture of what those represented. All right. So make sure when you do an inverse trigonometric identity, I want to see those triangles on your paper. It is part of the answer. It must be written so I know what you're talking about in all your work. Suppose, while people are still copying that down, suppose I'd gone with the cosine one here. So let's take that and shrink it up a little bit so I have room. Suppose I had gone here instead did cosine inverse of cosine of alpha plus beta. That's inverse cosine of alpha cosine of beta minus sine of alpha sine of beta. Cosine of alpha is square root of 1 minus x squared. Cosine of beta is x. Sine of alpha is x. Sine of beta is the square root of 1 minus x squared. This minus itself equals 0. Cosine lives from 0 to pi, and cosine equals 0 at pi over 2. Same result. Okay. Doesn't matter which one you pick one. Inverse sine of the sine or inverse cosine of the cosine. Once you get to just the angle measure, that's where you got to go from there on these inverse trig identities. And again, don't give me all the numbers of things. I mean, This was number 32, this was number 33. I don't care about that so much on these. I want to see these triangles, I want to see you go through the process properly.